Okay, so the main goal today is learn the basics of factoring. So we're going to start in a familiar place with distributing. So before, if we had this problem, we're going to distribute this 5x to everything on the inside, and I would get 15x cubed minus 50, whoa, didn't do that right, 50 x squared, and then plus 20x. So that's kind of what we would get if we distribute it over. And again, that process is called distribution. So that's what we did before. Today we're going to learn how to go back to the beginning. Us going back to the beginning, that's going to be the process called factoring. So it's really important that you think about what you do when you distribute, and you're going to do the opposite. So when we distribute, we take some kind of number and we multiply it to everything in here. So today we're going to look across some numbers and think about what number they multiplied. The other thing that we have to look for is like x's. So we multiply x's across. So today when we think about like factoring, we're going to think about, oh, what x's did they multiply across? So let's see a problem and like try to figure out what they did. So they're going to tell me to factor this problem right here. And so when I'm thinking about factoring, I want to have parentheses around my final answer because that's how we normally get started with like distributing. We had parentheses and then we had something out here. So we're going to figure out what that something was. Well, when I kind of look at these numbers, it looks like all these numbers have been multiplied by 4. Because 4 times 1 would give me 4, 8 times 2 would give me, 4 times 2 would give me 8, and then 4 times 3 would give me 12. So they went through and it looks like they multiplied all the numbers by 4. So that's what we're going to put down. And notice how I'm saying like, oh, like if I would have distributed that 4 times 1, there's my 4, 4 times 2, there's my 8, 4 times 3, there's my 12. So that's kind of how the numbers. Now I'm going to look at these x's. Well, it looks like I could have multiplied everything by a single x and been fine. And that would have left 3 x's on the inside here. Whoops. Only 1 x on the inside here. And then no x's on the inside over here. Now you can always double check your answer by distributing it and seeing if you get the same thing. So if we distribute 4x, 4 times 1 would give me 4, x times x to the third would give me x to the fourth. Perfect, I got the first one. This would give me 4 times negative 2 gives me 8, and x times x, oh, x squared, perfect. And then 4 times 3 would give me 12, and an x, oh, perfect. So we would, if we distributed, would get back to here. Let's look at a second one, okay? So when I look at this example, I want to think about my numbers and see if they multiplied through anything. And our numbers are 2, negative 3, and 5. And I can't think of anything they would have multiplied to get 2, 3, and 5. So we're just going to say, I don't think they used any numbers, so we'll just rewrite our numbers back in here. But it does look like they might have multiplied some x's across, because they all share at least 2 x's. So generally you want to put the lowest x's out there because that kind of tells you how many they could have multiplied all of them by. So that would have left, if I took 2 x's from here, that would leave 5 in here. If I take 2 x's from here, that would leave 2 in here. And if I take 2 x's from here, that would leave none. Well, if I distribute this, do I get back to the beginning? Yep. That would give me x to the 7th. That would give me x to the 4th. And that would give me x squared. So that's how they factored it. Let's look at 2 more examples. Okay, so again, we're going to try to factor. And this time I look at my numbers first, like always. Oh, I know what they multiplied all the numbers by. They multiplied all the numbers by 2. because 8 times 2, so that would be 4. And then this would be still -1, and this would be 6. So when I kind of went through there, I was like, oh, like that would make that work, that would make that work, and that would make that work, so we're good. Now I got to see the x's. Here's the problem. This doesn't have any x's. So obviously they didn't take a number and distribute an x through, because that last term doesn't have any. So my x's just stay the same, and they didn't factor out, and we can't factor out, whoops, any x's in there. So that would be our final answer. So sometimes you can take out an x, sometimes you can't, sometimes you can take out numbers, sometimes you can't. Let's try one more example. So we're going to factor this, and I go, oh, they multiply both things by 5. And I go in here and I go, oh, look, they even multiplied everything by a 2, because this is my lowest one. They definitely multiplied by 2 x's. So if I take a 5 away from here, I would only have 1. Then if I take an x squared away, I would just have a single x. This one, I really take away everything, because I take away its 5 and its x. So it's really just left with 1. And we can see that that would work, because if you do 5, if you distribute the 5, you'd get 5 and -5, perfect. And if we distribute the x squared through, we'd get 3 x's and 2 x's. So this right here would be my final answer. If you saw today, I checked every single one of my answers by trying to multiply back through and seeing if it worked out. That's a very, very good way of checking. So make sure today, try to think about what's the biggest number that you could take out. And then after you do that, see what's the biggest x you could have kind of multiplied through. And that's what we're doing.